Hello everyone, my name is Charles Pyfrom, and this is our digital watermarking project. I'm here with my teammates Mark, Manuel, and James. Alright, as some of us know, digital piracy poses a significant threat to the live entertainment industry, as unauthorized recordings and live streams can undermine the ability of performers to generate revenue from ticket sales and merchandise. To address this problem, we propose a project that explores the use of digital watermarking as a tool for authenticity, verification, and piracy prevention. So before we discuss the details of our project solution, I'm going to give a brief overview of what is digital watermarking, how significant watermarking is to the entertainment industry, and the threats that oppose them, and some of the real-life applications companies use today. So what is digital watermarking? Digital watermarking is a process of embedding an invisible or visible marker into digital media such as images, videos, or audio files. This watermark serves as a unique identifier that can be used to verify the authenticity and ownership of the media and track the distribution of unauthorized copies. By adding digital watermarks to live recordings of performances, performers can verify their authenticity and use the watermark to prove ownership and track distribution. So what are some types of watermarking? Visible watermarking involves adding a visible watermark, such as a logo or a copyright notice, over the digital media. An example of this would be where you're watching a YouTube video where the content creator puts their name faded out in the background or in the corner somewhere of the video. An invisible watermark is a technique where a digital watermark is embedded into the digital media without being visible to the human eye. Fragile watermarking is a technique used to embed a watermark in a way that makes it easier to detect if the media has been tampered with or altered. Robust watermarking involves embedding a watermark in the digital media in a way that it makes it resistant to various forms of attack, such as filtering, compression, and cropping. So how significant is the problem? The problem of unauthorized distribution and use of digital media is a significant issue for content creators, particularly those in the entertainment industry. Musicians, filmmakers, photographers, and other artists rely on their work for income. Without a way to protect their digital content, these creators are at risk of losing their revenue and recognition. So right now, there is a legal dispute among music labels and the use of AI. As great and groundbreaking as AI can be, it is already causing a disturbance in the industry. People are creating AI-generated music using bit-name voices like Drake mainly, and obviously that will pose a significant threat to their careers. It's important for us because as consumers, we need to be easily able to identify and verify the authenticity of the content that we consume. So that would go a long way in helping to prevent the spread of misinformation and fake news. So what are some types of attacks against watermarking? In a removal attack, a hacker attempts to remove the watermark from the digital media. This can be done through various techniques such as filtering, compression, or editing the media. In a modification attack, hackers alter some watermark media in some ways, such as by cropping, scaling, or adding noise. These modifications can distort the watermark, making it more difficult to detect or verify. In a collusion attack, multiple hackers work together to undermine the watermarking system. This can involve combining different versions of the same media to cancel out the watermark or sharing information about the watermark to improve their ability to remove or modify it. Here are a few digital watermarking patents that are used by companies today. Digimarc uses a technology process called Digimarc barcode. It uses a unique identifier to embed into the media content using a proprietary algorithm that can be embedded in the various parts of the media content, such as the pixels of an image or the audio signal of a video. The digital watermark can be used to track and monitor the usage and distribution of media content. It can be used to identify pirated copies of the content or to track how the content is being used and consumed. Verimatrix uses a patented algorithm that is designed to embed the fingerprint into the media content in a way that is imperceptible to the human eye. The watermark is embedded into the content at the pixel level, which makes it extremely difficult to remove or modify without degrading the quality of the content. It has the ability to embed multiple watermarks into the same media content. This allows for a range of different applications, including content identification, piracy, detection, and forensic analysis. Amazon uses a patented process called Amazon Authenticity Verification. It involves embedding unique code onto the product packaging using a digital printer during the manufacturing process. It also uses a two-dimensional barcode, a serialized number, and a unique pattern of dots and lines that are printed in a special ink. It is designed to be difficult to reproduce or counterfeit, making it a powerful tool for verifying the authenticity of products sold on Amazon.
Okay, so now this is the proposed design. Okay, so first we have the functionality requirements. So the first functionality requirement is that the system should be able to embed the watermark into the digital content using techniques such as visible and or invisible watermarking. Next, we'll have that the system shall detect the presence of the watermark in the digital content and that the system shall accurately locate the watermark within the frame to identify its origin or ownership. Fourthly, we'll have that the system shall be able to maintain the integrity of the watermark even when the digital content is subjected to common image or video processing techniques, such as video compression, or cropping. Fifth requirement is that the system shall work with a wide range of digital formats or devices to ensure that the watermarking process can be used in different contexts and by different users. And the sixth requirement is that the system shall customize the watermarking process to meet the specific needs of the content, such as the type replacement of the watermark. The system shall also be able to embed the watermark quickly and efficiently without causing issues in performance or delays. Because we're going to be working in a CDN-based system, and mainly with like live stream content. And when it comes to live stream content, seconds matter. The difference between good user experience and bad user experience can literally just be a matter of seconds and delays in the live stream content. So this is very important. So here we have the usability requirements. So the system shall be simple and straightforward, clear instructions. Should also be visible enough to deter unauthorized use, but not obtrusive that it distracts from the content itself. And it should allow control over the watermarking process, including the ability to choose the type and placement of the watermark, and the ability to remove or modify the watermark if necessary. Should also be robust enough to withstand common image and video processing techniques, such as compression or cropping, without being degraded or lost. So we don't want to lose the quality of the image during the watermarking process. So here we have the safety requirements. So it needs to be secure, compatible with system and tools. It can't take up a lot of CPU or memory, and it should also not have any harmful or malicious code. And the integrity of the watermark, and should not compromise the integrity of the digital content, as well as staying within the relevant regulatory requirements. Our initial design was going to be a GUID approach, where we generate a unique ID for each user. We would then apply this GUID as either a text overlay or as a binary sequence of numbers and then embed it within the video. We would store the GUID in a database, and then once we extract the GUID from the video, we would then compare it to what we have in the database, and we would be able to then validate each user. Now, this is definitely functional, but it's not very efficient. The reason why this isn't really a feasible solution, though, is because we use a CDN-based cloud architecture, and the problem with implementing a GUID is that it would require us to do a lot of computation on the CDN side, and we need to store the GUID in each and every single video. And each and every single video would then be handed out individually to the user instead of different fragments of videos, which is a much more efficient and quicker process on the CDN server side. So this wasn't very feasible for our solution, at least in the cloud. So our current design is implementing the A/B watermarking method. This is a much faster, much more efficient process, especially when it comes to the cloud architecture CDN-based system that we work in. The way it works is we have a video. We create 3 distinct copies of the video, so low resolution, high, and medium. These are then subdivided into the watermarked videos type A and type B. And these different watermarked videos of type A and B are then further split into fragments, and these fragments are then stored in a CDN for distribution. This is a much faster and much quicker implementation. So here's a representation of the A/B watermarking system diagram. Here we have the original video, and that original video is split up into video quality type low, medium, and high. and then we apply the watermark to these different qualities. So we'll have a distinct copy of low of type A and type B based off the watermarking system that we do. So these three video quality types will be then further divided into fragments, which will then be 10-second or 20-second fragments, which will then be shuffled into a CDN. Inside the CDN, all the CDN does is it just stores these fragments, and the user will be requesting access to these fragments, and the CDN will be dishing out a unique combination for each user. While it's doing that, it'll be reading their bandwidth, and based off their device and their bandwidth, the CDN will be giving out fragment type A of low, medium, and high, and the same for B. So the user will be getting a unique combination each time, and we don't have to sacrifice quality because we already store the different video fragment qualities inside of the CDN.
Hello, my name is Manuel Castro, and I've been presenting to you our implementation for our project of watermarking. So the main goal of this project is to be able to implement it in the cloud. That means that our project is going to be running in an AWS server. That is the one of kind of services that they use in Warner Bros. To with the CDN to content delivery, the streaming for the users, right? That means what happened there? We our application we planning to use an S3 bucket for storage, and also we'll be using the EC2 as a virtual machine. In that virtual machine, we will install all the dependencies that we need for our application, like the Docker container and all the logic. And then from there, we'll be running the different service of our application in the cloud. At the same time, they will be providing services to the CDN of Warner Bros. Right now, we were testing in different environments. Also, we're gonna explore the services for AWS, like for example, the Amazon CloudFront and other services. Now, let's analyze how our application will be integrated in the Warner Bros. CDN services. Okay, we start from original video. That original video will be applying a watermarking. The watermarking that we're using for this demo will meet a visible watermarking, right? And we will be using the need of A/bit watermarking, right? So what happened from there? From there, we're gonna have a result to different videos, right? Video source. With every video source, gonna have apply a different watermarking, right? After that moment, what's gonna happen? What happened in the real in a real video on the internet? You don't send the whole video. The video is being sent by package, being a small package that go to your browser, and then your browser start to play in the video. That's what we're doing there. We are splitting that watermarking into a small packets, right? What happened? Those small packets normally are a small packet of 10 seconds, right? In this case, it's gonna be what is called a TS file, and we're gonna have the TS file with the watermarking A, the TS file with the watermarking B, and also one fragment of TSS that's not gonna have no watermarking at all. Now, this is gonna happen. This part here we happen in the CDN. What the CDN is gonna do? The CDN is gonna be shuffling the different the different watermarking A or B, they're gonna be shuffling, so we create a unique streaming for every individual user. We're gonna have a database where we wanna be storing what is the sequence that we are delivering to every user. This is an example of one sequence. In that case, we apply a watermarking for one video that's gonna be XYZ, and then we apply another watermarking for another video that's gonna be UBW, and then when we cut that video into fragment, we start to shuffling the fragment, and we create this unique combination that's going to identify the user, right? Also, at the same time, our application we have some Docker container that we connect with those shuffle video, and we'll be able to do several processes like the tampering to see if after applying some techniques like, for example, blurring, like resizing, cropping, or something like that, our watermarking is able to hold, and we are able to validate. After we apply those tampering process, we're gonna go to compress the video, we're gonna convert back to fragment, and we're gonna validate that fragment. That means be checking if we can read our watermarking from the video, from the watermarking we apply, and that will correspond to the watermarking that we expect, right? This video is gonna be streaming from the user. Also, in our system, we're gonna have some like component of the system that gonna be checking for over the CDN, we will checking for signal that we suspect is a pilot signal, and then we will try to validate to see in that signal we can find our secret. If we find our secret, we're gonna be able to know which is the user that we are streaming that specific sequence, and then we can, the company Warner Bros. Can take another message in regards of that. For our watermarking application, we're using several technologies. We're using, for example, Python as a programming language that's going to be the one that's going to be running all the video relating processes. Also, we're going to use JavaScript. We're going to be using React, Bootstrap, and HTML to create the UI, the front end, and also the back end of our application. In the back end, we're going to have a Node.js server, and also we're going to be using MongoDB as our database to store all the independence, all the independent sequence that we're gonna be creating the watermarking. Also, we will use FFmpeg, that is a library with Python, to do process on the video, OpenCV, and we will be implementing a WebSocket server in that case, so we can do a streaming over the video from our application. This diagram represents our web application demo we're displaying today. This application is going to have like different parts. First part is going to have a UI, going to be a website, right? That the user is going to be able to input the video that he wants to apply the watermarking, right? And then when the user input the video, he will press submit. And what's going to happen? That video is going to be we're going to be sent back to the backend, and then from the backend is going to create a new Python container, and it's going to copy back the original video to the Python container. That Python container will be an image that already has pre-installed all the different libraries and framework that we need to process our watermarking, to also do the tampering and do the validation. And then when the container is running, the container will apply the watermarking following the unique sequence that we generate, the watermarking I/bit for that specific user. When that is finished, the container will copy back to the backend the video, and then the backend will send back the video again to the UI from the user. And then the user will be able to run the original video and also see the watermarking video. At the same time, the user will be shown what's going to be the percent of the validation success that we have on that specific video. One of the most important concerns about the watermarking the video is to be sure that after we apply watermarking, we are able to retrieve or to validate the watermarking. Some condition in the network can happen, like loss of packets, like problem with the connection, that can do that. For example, the validation cannot be the watermarking cannot validate it back. And for other side, can be sometimes the users can apply some filtering, some cropping, some resizing that can do that our watermarking not be able to retrieve from the video. That's why in our application we're trying to our watermarking process to do some stress tests in that watermarking to make sure that survive the different process, like for example resizing, cropping, also change the frame per second, also applying Gaussian nodes, Gaussian colors, and different techniques that we can use to modify the video. In our current demo, we have implemented n watermarking A/bit, but we are using what is called a visible watermarking. That means we are applying a visible layer to the video, and then we are splitting that video in chunks, and we are missing the chunk to create the watermarking A/bit. One of our goals for the future implementation of this project is to be able to apply an invisible watermarking. To do so, we are doing some research, and we are learning different ways and techniques that we can apply an invisible watermarking on a video, and also make the video robust and make it fast at the same time.
Hello, my name is James Quinapala, and today I will be discussing the watermark embedding and extraction method research. First, I'd like to talk about the spatial domain. The spatial domain is the state of an image as we perceive it, a matrix of pixels where each pixel is made up of 3 light intensities. Depending on each intensity, the pixel will appear to be a different color. Next is the frequency domain. The frequency domain is the state of an image that is converted from the spatial domain through a mathematical transformation. But rather than displaying the normal image, the frequency domain shows the rate of change of the pixels across the image, showing higher frequencies when there are adjacent pixels that are opposite in intensity. Spatial domain watermarks were very common for a time, but have shown to be very susceptible to tampering in the form of image manipulation. Frequency domain watermarks are the most popular type of watermark today because they excel at resisting different types of tampering techniques, and within the frequency domain it is easy to identify the most significant or least significant portions of an image where you may want to place your watermark. Next, I would like to discuss discrete cosine transformation. DCT is a way of converting and dividing an image into sections that are represented in the frequency domain, where you can easily identify and remove the least significant parts of the image. Discrete wavelet transform can take an image and separate its frequencies into 4 distinct bands, each representing a different region of the image where the frequency is high, low, or a combination of the two. DWT is likely the most popular watermarking technique today because it excels at identifying edges and textures, which are in the high frequency band. Also, it is important to note that DWT is often used for noise reduction, so it is also very capable of concealing a watermark, because a watermark can be considered to be a type of noise, but noise that needs to be preserved. Next, I'd like to consider one of the solutions found during our research: spread spectrum watermarking. It is a type of watermarking developed by Ingemar J. Cox and his peers. It is very robust and capable of resisting many types of tampering. An important aspect of spread spectrum watermarking is that it spreads the watermark across the entire image, so that if attacked by an image crop, it is very likely that the watermark will survive. Additionally, Cox and his peers considered a fundamental aspect of watermarking and its effects on image quality. Often, watermarks are placed in the least significant portions of an image so that degradation to the image is less likely. However, placing a watermark on the most significant portion of an image can be used as a potential defense mechanism against attackers. If an attacker removed the least significant portion of an image, it is likely that the image was still in a good enough quality and the watermark would be lost. But if the watermark was placed in the most significant portions of an image, then it would require that the attackers severely degrade the image to remove the watermark, which at a certain point would make the image useless to the attacker. Next, I'd like to go over our development plan and schedule. Here is an outline of our plan. First, we need to investigate multiple watermarking methods in the spatial and frequency domain. Second, we must apply and implement some of these watermarking methods and solutions to gauge their viability. Third, we will need to validate and extract our watermark. We have to tamper with, and then fourth, we have to tamper with the video in a variety of ways to test for watermark survivability. Fifth, we will build a UI to interact with our system. Sixth, we will prepare our AB watermarking method system design so that it is capable of functioning within the cloud environment. Here is our work breakdown schedule. First, we will have investigation and research, which is ongoing and will be done by all members. Next, we must apply watermarking embedding methods. We should be done with this by May 27th, and it should be done by Mark and James. Third, we need to extract and validate our watermark. This should be done by June 3rd and shall be done by Manuel and Mark. Next, we need to tamper with the video. This should be done by June 10th and will be done by Charles and James. Next, we need to build our UI to interact with the system. This should be done by June 17th and will be done by Charles and Manuel. Next, we need to make sure that we complete our working local environmental digital watermarking system. This should be done by July 1st and will be completed by all members. And lastly, we need to prepare our AB watermarking method and system design for cloud compatibility. This should be done by July 15th by all members. The reason I made the final due date, July 15th, is to give ourselves a couple of weeks in case we run into any unknown factors or emergencies. Here is a list of the assigned tasks. First, we have Mark, who will be applying watermarking embedding methods and extracting and validating the watermark. So those are the two components he will be working on. The two components Manuel Castro will primarily be working on is extracting and validating the watermark, as well as building UI to interact with the system. For James, he will be applying watermarking embedding methods, as well as tampering with the video. For Charles, he will be tampering with the video and also building a UI to interact with the system. For all members, they must investigate and research, as well as prepare the A/B watermarking method and system for cloud compatibility. For our budget, uh, it's not really necessary to mention our costs because all of the software, IDEs, research, and coding libraries we are using are open source. For our hardware, we are using our own personal computers. The development of our system for this project will be free. However, for our solution to be implemented on a large scale within the cloud will likely require a budget that we cannot predict. But I believe that this aspect of the project can be aided with the help of our project sponsor, BuildTrack. Okay, this is the conclusion of our proposal presentation, and we will next be going into our current demo for our prototype.
Hello, my name is Manuel Castro, and I'll be doing today a demo for our application for watermarking. First of all, I will initialize my server. So we have our server working. Our application is do it using a backend in Node.js. Also, we are using a UI. We are using Bootstrap to sterilize, and also we are using a Docker container in which we install a Python image, and also we install all the different dependencies and framework that we need to run our watermarking process. That will be like OpenCV, that will be like FFmpeg. We will use also Tesseract to be able to read it in the OCR for the visual watermarking. And then let's gonna start. This is our code here. We have a public section where we're gonna storage here. As you see, it's totally empty this moment. I have some, for example, some video to test today, right? And then for here in the video, we don't have no information at all. Also in our Docker container, we can see we only have the code of our, let me delete this input video, so we don't have nothing here right now. Everything is empty. We don't have any input video in our Docker and everything. So let's start. So the first thing that we do here is we're gonna, from our UI, we're gonna select the file, select the video file. From here, I have some example like this one here. Let me select this one, right? And then we're gonna open and we're gonna submit. In the moment that we submit the video file, let me go to my network so we can see what is happening inside. We're gonna see the terminal, what is happening inside the container. Let's submit. Okay, first thing, we are executing a Python container, as you can see here. And then we create a new API call, a new fetch to our backend, right? What is happening inside in this moment is we are starting a new container in Python, and then we're gonna start using the several scripts so we process. Right now, we are ready, finished to process our video, and then we receive the original video, right? You can see here in our screen, right? Let me put it bigger so you can see. This is the original video that we just input, and here we have the video with, in this case, with the, let me show you so you can see, guys. We have the video here with the watermarking. You can see we apply a VCO watermarking, and then that watermarking is changing for the video. And now, how this one is happening? Let me go back again. Okay, and here we have, as a result, we have here what's going to be our stretch rate. What is the percent our stretch rate? As I show you here, when we did that one in the public, the video was empty. And what happened here? We sent, like I said, to the Docker the input video, and then they're gonna do the Shufer watermarking. That means we're gonna create and we're gonna storage here in a DB from the user. We're gonna store a unique sequence for the watermarking, and then here we can see in the code we're gonna apply that one using FFmpeg to the watermarking, and then we're gonna shuffle here using this loop. We're gonna split in fragments the video, and we're gonna try to simulate an I/B watermarking process. So, and we're gonna have two different watermarking video. One where, let me show you here. Okay. So one watermarking video with A that's gonna have X and C, and one watermarking B that's gonna be UBW, right? And then we're gonna split that one, and with the chunks of this video, we're gonna start to shuffle the chunk to create a unique sequence of video that's gonna be independent for every user, right? And here, for example, when the container start to working, we sending back our extract rate. As you can see here, we sending the original video back and we sending a low quality with that watermarking here. We have the two, the A and the B, that's gonna be UBW, and the other will be XYZ. And also we have here the chauffeur watermarking output, and also we have a high quality watermarking feed for XYZ and a high quality watermarking UBW, right? Now, and we have that information here. And if, for example, if we run the video, the watermarking video, that's gonna be the output here. If we run it here, you will see like that one is changing, and that's gonna be unique every time we run the container. Okay, so now let's test another video so you can see with a different like outcome. So we come back to our UI, we have the UI here, and then we're gonna select a different video. In this case, we're gonna select this one blue that I record in my desktop, right? And then I'm gonna submit the same process we have. You see here. Before you used to see that we have that video that's gonna be like that one that we have here. And again, we are executing the Python container. The Python container is initializing all the libraries for FFmpeg, OpenCV, and it's running all of our script. Again, and then with this code finished to do, we're gonna have in our public video, we're gonna have the output of the watermarking process. So let's wait for this one. Sometimes some videos take a little longer, some videos take, that depends on the quality of the video, that depends on the duration of the video. This video is a little longer, it's a 14-second video, right? And also we need to initialize the container. Okay. Okay, here. Right now the video is totally. We get here, you can see a 97.62. And here you can see all the logs for all the things that happen inside our container, all the validation process, all the apply watermarking process with the different commands. You can see here, for example, when we create the different like image for the container running the different Tesserato CR, the different thing that we use to be able to produce the result. And here we have again the same. We have our video, the import original video, and we have the watermarking version of that video that you can see here. That is gonna be a different, like you see how it's changing. The watermarking, perfect. Okay, and now inside of our Visual Studio, you can see in our let me let me put the video stop. You can see here inside our Visual Studio again, we have again the same. The input video, the low watermarking quality, also for A from B, that means for OUBW, and also for XYZ. And we have our trophy, that's gonna be the result, and we have the Hawaii quality watermarking for the two different feeds, right? And then as always, we have a to set your rate, okay? And that is all from the perspective of the demo. What is happening inside here? That's it.